Got a case study for you. Let me tell you about Marie. She was a healthy woman in her late 30s. She'd always been an active person, but at some point her energy level just seemed limitless. She was walking the dog 4 times a day, up at 5 in the morning, emailing her coworkers, and at midnight she was still awake, like dusting the ceiling fans. At first she felt great, she was super productive, but soon she started having trouble sleeping. She felt anxious all the time, she lost a lot of weight and noticed that she felt hot and sweaty when no one around her did. She started experiencing heart palpitations. Then one day her vision seemed blurry, and when she looked in the mirror, she was kind of surprised to find that her eyes were actually bulging out of their sockets. So yeah, she finally called a doctor, cause you know, bulging eyeballs. Marie's doctor referred her to an endocrinologist who, after running some tests, determined that the root of her problems was in her thyroid gland. The thyroid is one of the stars of your endocrine system. It's the little butterfly-shaped structure located anterior to your trachea and inferior to the larynx or voice box. It may look cute and unassuming, but don't be fooled. The powerful hormones that it produces influence some of your most important physiological processes. These hormones, and many others, help maintain your chemical homeostasis, the balance and concentrations of substances like calcium, sodium, even water within very narrow ranges so that your body can provide a consistent internal environment for your cells. Your cells and the proteins in them need that stable environment to function, so if your body loses its homeostasis too dramatically, cellular function will stop, and as we say here on Crash Course Anatomy and Physiology, you will stop being alive. So your thyroid helps you avoid such a fate by secreting hormones that regulate many aspects of your body's homeostasis, like body temperature, skin moisture, and your blood's levels of oxygen, calcium, and cholesterol. It should come as no surprise that if the thyroid malfunctions and produces too much or too little of a hormone, it can lead to all sorts of weird and serious symptoms. And yet, thyroid disorders and the hormonal imbalances that accompany them are pretty common. It's pretty likely that you know at least one person, most likely a woman, who has experienced an issue with a dysfunctional thyroid, and many more of us are walking around with thyroid disorders and haven't even been diagnosed yet. In Marie's case, it turns out that she had Graves' disease, an immune system disorder that results in the overproduction of thyroid hormones, or hyperthyroidism. Although it's just one type of hormone disorder, looking at her symptoms can help us understand just how important, influential, and interconnected hormones are, and why they need to be properly balanced to maintain healthy homeostasis. And I cannot say this enough, homeostasis is life. Last time, we talked about hormone cascades and how a lot of the hormone activity that's bubbling along inside of you is the result of one kind of hormone bossing around the cells that produce another kind of hormone. These pathways typically start with an internal stimulus, often coming from the hypothalamus or pituitary gland, and end in the target glands that release hormones into the blood to get the real work of living done. We've seen how this kind of cascade controls your body's stress response through the hypothalamic pituitary adrenal axis, or HPA axis. Basically, your brain tells your hypothalamus to tell your pituitary to light a fire in your adrenal cortex, and in no time they've shut down digestion, released a bunch of energy, increased your blood pressure, and everything else you need to either fight or flee. And that's great! Your HPA axis is super useful when you are under stress and need to take action. But you do not need your adrenal cortex spouting off all the time. The truth is, much of the more basic, more fundamental business of everyday life is carried out by a different kind of cascade. It's the hypothalamus pituitary thyroid axis, or HPT axis, and it's what sets the thyroid gland into motion so it can regulate just about everything related to your homeostasis. For example, let's say you're caught outside on a cool day and you're underdressed. So let's say you were on a bus, busily texting your bestie, and you got off at a stop while searching for the emoji that most accurately depicted your reaction to the new Avengers movie when you realized that you'd left your jacket on the seat. There's nothing you can do to get your jacket back, but your hormones can do something about your coldness. Now, your nervous system, of course, has its own ways of detecting and signaling a change in temperature, but your endocrine system gets involved as soon as it senses that the temperature of your blood has changed. Your cooler than normal blood flows into your brain's hypothalamus, where it bumps up against temperature-sensitive sensory neurons, which act like a kind of thermostat. Once they detect that the temperature is below target levels, those neurons secrete thyrotropin-releasing hormone, or TRH, into the bloodstream. TRH is a tropic hormone, which means that it gets the hormone cascade started by triggering the release of other hormones. The cascade starts off with just a trickle as TRH goes just a few millimeters to the anterior pituitary, where it hits receptors on cells there, causing it to release thyroid-stimulating hormone, or TSH, into the bloodstream. That then travels down to the thyroid, finds its receptors, and slaps the gland to attention so it releases its own special thyroid hormone, hormone into the blood, where it can affect virtually every cell in your body. Like steroids, thyroid hormone is lipid-soluble, so it crosses the membrane of its target cell to bind inside the nucleus. There, it can make the cell either increase, decrease, or maintain its primary function. In this case, since you're feeling chilly, your body needs to stoke the fire a bit, and it does that by burning glucose. In your cells, burning glucose really means breaking it down so its component parts can be used to produce ATP. Thyroid hormone comes into play when it binds to receptors inside the nuclei of your muscle cells, triggering the transcription of DNA that makes the enzymes to break down that glucose. With more of these enzymes flowing around, more glucose is being broken up and more ATP is being produced, which is all a long way of describing the process that we call metabolism. But since the thyroid has increased the amount of chemical reactions going on, it also increased the amount of waste heat that's being generated. So this process has a calorogenic or heat-producing effect that helps warm you up. Now, whether or not you happen to forget your jacket on the bus and found yourself shivering on the way to work, your thyroid hormone produces all kinds of other effects as well, like maintaining your blood pressure, promoting the growth of tissues, and triggering the secretion of digestive juices to keep food moving through your digestive tract, just to name a few. So, thyroid hormone for the win, right? What's not to love? Well, what's important about the whole HTP axis is not just how it works, but also how it knows to turn off. Your glands need negative feedback in order to know when their job is done so they can stop secreting certain hormones. That's where your pituitary and hypothalamus come in. Remember, they're always monitoring hormone levels in your blood. If there's too much thyroid hormone, they both decrease their own hormone production to stop stimulating the thyroid. That, in turn, reduces thyroid hormone levels in the blood and slows down your metabolism again before you get overheated. At least that's what happens if everything's working the way it should. But there are millions of Maries out there. Plenty of people, maybe even including you, who know full well that hormonal imbalances, thyroid-related or otherwise, happen all the time. Why? Well, thyroid disorders can be caused by lots of things, but in the case of our Marie, it's autoimmune dysfunction. Normally, when you get sick with a virus or bacteria or what have you, your immune system responds by sending out antibodies that target those invaders. Now, we don't fully understand why yet, but if you have something like Graves' disease, your body produces abnormal antibodies that target the cells of your thyroid gland itself. And instead of marking those cells for destruction like antibodies normally do, they do something even more bizarre. They mimic the hormones that the pituitary gland sends out, which bind to the thyroid's receptors. So even though the pituitary dials down its hormone production in an effort to get the thyroid to stop, the thyroid does not get the message because the receptors are still being activated. Basically, the gland never receives any negative feedback, so it just won't quit. And if your thyroid doesn't stop, it's hard for you to stop. So that's why Marie was always hot and sweaty. Her hypothalamus was screaming that she was warm enough, but those antibodies were hijacking the hormone cascade. And she was losing weight even though she was eating all the time because the thyroid hormone was no longer regulating her metabolism properly. But what about those big bulging eyes? Remember those? That was weird. Well, because they're part of the immune response, those disruptive antibodies often cause inflammation, particularly in the tissues around the eyes. In some cases, the swelling can be so severe that the eyes are no longer able to close. Treatment for Graves' disease involves either inhibiting the production of thyroid hormones or blocking their effects, basically getting your body chemistry back in order. The moral of the story is that hormones mean business, and by business I mean living, and by living what I really mean is, and everybody say it together now, homeostasis. In addition to learning to respect your hormones and thanking them for helping you live, hopefully today you learned something about chemical homeostasis and took away a greater understanding of hormone cascades. Specifically, we looked at the hypothalamus-pituitary-thyroid axis, or HPT axis, and all the ways your body can suffer when that system, or your hormones in general, get out of whack. Thank you to our headmaster of learning, Thomas Frank, and to all of our Patreon patrons who help make Crash Course possible through their monthly contributions. If you like Crash Course and want to help us make it available for free for everyone, you can go to patreon.com/crashcourse. Crash Course is filmed in the Dr. Cheryl C. Kinney Crash Course studio. This episode was written by Kathleen Yale, edited by Blake DiPestino, and our consultant is Dr. Brandon Jackson. It was directed by Nicholas Jenkins, the editor is Nicole Sweeney, our sound designer is Michael Aranda, and the graphics team is Thought Cafe.